Everyone, it's Alan again. Equations involving inverse trig functions is what we have left in this chapter. So here comes another video for you. Hopefully you're finding these much better than any of the other things that you were trying to do in order to comprehend the material. But this one's not that involved. It's basically just making sure that you understand what the inverse does and how we can utilize it to solve equations, just like we've been working on in the previous two sections. So without further ado, here we go. First thing I wanted to mention to you all is making sure that we understand what the inverse is, because that's how these equations vary compared to what we've seen in the previous two sections. So if you remember from algebra, it was just inverting or reversing our input and our output, our domain and our range, our x and our y values is what we typically used. In trig, remember, we sometimes still use x and y, but the inputs are usually angles and the outputs are usually numbers. Whether they're ratios or real numbers, it's totally dependent on the question itself. So in this case, we're just going to have to make sure that we know how to use specifically the inverse. And again, I'll review that with you all real quick just to make sure algebraically we remember what that represented and how we used it. So for example, let's say we had something like y equals 3x minus 4, and we were asked to find the inverse of that. Well, basically what we would do first is take the input and the output and keep everything else the same. But we would just reverse our inputs and outputs. The problem is if I asked you to graph an equation that was x equals 3y minus 4, it'd be much more difficult for us to do because what we're used to is y equals. So in this case, what we're going to try to do to finish is take this equation and actually make it y equals again. So our first step would be to solve by adding 4. So now we got 3y on one side of our equal sign and x plus 4 on the other. And then lastly, we would take that and divide everything by 3. And that would leave me with a 1y equals 1/3 x, if you see it there, plus 4/3. And that would be my equation. That is what is called the inverse of my original. So to let you know that it is the inverse compared to the original function that we're calling y, we have to make sure that we put some type of symbol up there to let you all know that, hey, this was my original function and this is my inverse. And so again, just like we reviewed earlier, we know that that is going to be that little -1 exponent to represent the inverse solution. So with trig, same idea, but this time, instead of giving you only one variable, sometimes they're going to give us two now. So again, if I was to tell you y is equal to sine of 3x, I still want to find the inverse of that. So this first example here, we're going to be trying to solve for x, but notice that they gave us a restriction on our interval. Now remember, when we were talking about inverses, we had to make sure that we understood that we only wanted things that were functions, and not just functions, but one-to-one functions. Because when we find the inverse and we take the x and the y, the input and the output, and we flip-flop them, we need to make sure that what we come up with is also a function. And so if you remember, when we talked about this earlier in the chapter, we were talking about the horizontal line test. And so we had to restrict our domain for this in order to make sure that the horizontal line test passed. And when we find the inverse, that it gave us a function as well. So in this case, we're going to try to isolate, just like we always have in solving for x. So the first step we have to do is make sure that you know that that is an angle. And so I put parentheses around it just to let you know. I'm always going to try to isolate first my trig function. So in this case, I'll go ahead and divide both sides by 4 first so that I get my trig function all by itself. Because now I have y over 4 on one side, and that's now equal to tangent of an angle. Happens to be of 3x. And if you remember, when we had a trig function by itself, the input, which was typically our angle, usually when we had the angle, gave us the output, some ratio, some number. And in this case, in order to take the input, my angle, and the output and reverse their order, I got to make sure that I let you know if I'm going to switch that. Can I simply just put this? Is that okay? And hopefully you answered. I didn't hear you. You need to speak up a little bit. Just kidding. Hopefully you said inverse. You need to put arctan or to the -1 power inverse tan. That's what tells me that my input, which normally my angle was 3x, and the output, which is my y/4, have been flip-flopped. Now remember, the whole reason we're doing that was because we're trying to solve for x. And I'm almost there now. All I got to do is undo the multiplication by dividing that whole thing by 3. Or you can also say multiplying by 1/3, because that then allows me to say that my answer for x is, I'll go ahead and write it as 1/3 arc or inverse tan of y/4. And you might be wondering, because of the equations that we solved previously in the section before this, what else is there to do? That's it. We have now solved for x and we are done. And you may also be wondering, well, what about the -π/6 to π/6? That was just to restrict our domain so that when we found this right here, it now is also a function. If you look at this second example, we actually only have one variable, and that's x. So when they ask us to solve the equation, we know we're solving for x again. And notice I bolded it for you. They may not always do that. They're going to ask us for exact solutions, which is good for us. That means we don't need a calculator, but we do need to know our reference angles. So in this case, always, anytime you see a trig function, you want to isolate it and get it by itself. Now remember, this is my quote unquote angle. In this case, it's arctan, so it's not actually going to be an angle. They've already applied the inverse. So I'll talk about what that means in a minute here, but first things first, let's try to isolate that thing by getting rid of the multiplying by 3. Let's divide both sides by 3 to get arc or inverse tangent of x equal to π/3. Now, if you remember on previous videos, I told you guys whenever you're asked to find an inverse, that you're going to be asked to find an angle, which is why, since this says arc, we are given an angle here. But our goal is to solve this equation for the unknown, the variable, the x. So how do we get rid of arc tangent? Well, to get rid of the arc, the inverse, we just do the inverse of that, which means I take the input and the output, and normally we would put the arc or the -1 power. Well, since it's already there, we're just going to get rid of it in order to switch those inputs and outputs. And that will then yield the regular old tangent function. So in this case, I will now have tangent of π/3 as my input, and it's all equal to x. Now, in the previous example, we stopped there because there was more variables involved. But this time, we should know exactly what that's asking of us. And in this case, we should know that π/3 is 60 degrees. So we're looking for the tangent of 60. And if you know your reference angles, then you know that is equal to the square root of 3. And you have found the exact solution for this. Pretty straightforward. It's a nice way to end the chapter. Hopefully you guys are hanging in there.